All right, sorry about that, guys. Ran out of video. Okay, let's keep going. So we have the equation, the y equals 1.3x. That's our slope plus 44.38. Okay, so there's the equation. The next part is asking us to use the line of best fit, which means use our equation that we just created. And it says, estimate the number of goals a soccer team could score in the year 2012. Okay, so let's remember, this was year 0, and then we had 1, 2, 3, 4, and 5, right, for year 10. So we have 2011, and then we'd have 2012. Well, if this is 5, this one would be 6, and this one would be 7. So that means in the 7th year since 2005, they're asking us to estimate the number of soccer goals. Okay, so that just means that I'm going to take my equation of y equals 1.31 times 7 plus 44.38. Okay, so I'm going to put that in my calculator. So hang on just a second. Okay, so this is where we probably are on our calculator. So let me show you how to get to another page. We're going to do Control and Dock to add a page, and then we're going to say number 1 to add a calculator. And so now I'm going to type that in. It was 1.31 times 7 plus 44.38. Enter. So my answer would be 53.55. So let me go back to our problem. Okay. I was hoping to get it all back on there. It's not going to come. Okay. So it was 53.55, correct? So 53.55, and since we can't have half of a soccer goal, and it is just an estimate, then we can go ahead and I'm going to round up because of this number right here. So we're going to say 54 goals. The other thing it said, what is the correlation coefficient for the line of best fit? Okay, so again, that means we need to go back to our the calculator. So let me flip back to there. And let me go back to the page we were on before, and I'm looking for the R. Remember, the R is our correlation coefficient. So right here, so we have 0.713, and remember, I want to the second place, so I'm going to look at the next number, the third number. That is less than 5, so I'm not rounding up. It's going to stay as 0.71. So we flip back over. So my answer here is going to be 0.71 for 6C. Okay, number 7 is saying what are the domain and range of the data? So remember, domain would be our X values, and range will be, let me get another color. Range is going to be the Y values. So let's start with the domain. If I'm looking for my X values, sorry. Okay, domain values would be the X values. So I am wanting to look at each point. I'm going to go down and I'm going to get those particular points. Because remember, this is a discrete graph. I have individual points, so that means I'm going to have individual numbers for my domain and my range. So you can see that I started at 65 and I've gone every 5 up to 105. So we're going to write that down. So it was 65, 70, 75, 80, 85, 90, 95, 100, and then 105. That takes care of my domain. Now let's look at the range. The range would be the Y values, which are all going to be over here. So that means I am going to, again, take each point and go over here towards the Y-axis and get those numbers. Okay, now this is going to get real squishy. So I'm just going to go back and let's just write them down. So this one would be 0.5. The next one is between 0.5 and 1, so that looks like it probably would be 0.75. And there's actually two of those, but remember we only write it one time. The next one is right here. It looks like it's between 1 and 1.5, so 1.25. My next one is on the line. It's at 1.5. My next one is way up here. It is between 2.5 and 2. Sorry, it's between 2.5 and this should be a 3. That was funny. Okay, so that's 2.75. And the next one is up here between 3.5 and 4, so 3.75. And the next one between 4 and 4.5, so 4.25. And my last one is way up here between 4.5 and 5, so 4.75. Okay, good job. Number 8 says, based on the data in the scatter plot, what would you expect the y value to be for x equals 2020? So these are my x values. These are the years. This is 1990, 1995, 2000, 2005, 2010. So then we would have 2015, and then we would have 2020 down here. Okay, so if you just kind of look at the direction that that my points are going, you can see it's going down, right? It's a negative correlation, so I'm going to keep going down probably. So let's look at our answer choices and see if we can figure this out. A says it's going to be greater than 80. Well, guys, 80 is right here. This point down here is definitely not above 80, so that's not going to be it. The next one says between 80 and 65, so 65 would be here. And that means up here in this general area somewhere. Again, this point way down here is not up there. The next one would be between 65 and 50. So that means in this general area, somewhere in here. Again, this point, not in that area. So then it says less than 50. Well, obviously it has to be less than 50. So D is going to be the correct answer. Okay, number 9 says write an equation in slope-intercept form that has a slope of 5 and a y-intercept of 0, -2. So just reminding you, slope-intercept form looks like this, y equals mx plus b. And here's my slope, that means that's my m. And my y-intercept is 0, -2. So remember the y-intercept is this number right here when my x is 0. So my y-intercept, which is the b, is -2. So we have y equals 5x minus 2. So here's the answer for number 9. Now let's look at number 10. It says write the equation from number 9 in standard form. So if I'm starting with y equals 5x minus 2, remember, standard form looks like this. It is the ax plus by equals c. So all I need is that my x and my y terms are on the same side of the equal sign. So that means if I move my x term over here to the left, I will write my x term first. I'll have my negative 5x. And then I have a positive y equals, this is gone, and I bring down my -2. So now this looks just like this, right? The x and the y's are together. So there's my answer for number 10. Okay, number 11 is asking us to match our graphs with these words over here in our word bank. So let's start with the correlations. Remember, a positive correlation is going to go up like this, a negative correlation is going to go down like this, and no correlation would just be everywhere. So looking at, let's see if we can find the positive correlation first. Okay, it looks like this one is going up in that direction. So we're going to say this one is the positive correlation. All right, let's go and try to find the negative correlation. This one looks like that's going to be it. We're going down in a negative direction. And then obviously this one is just kind of all over the place, so there's absolutely no correlation here. All right, let's go to the next part of it. So we've taken care of all of these. Now we have the correlation coefficients. Remember, the closer the information models the data, the closer this number is going to be to 1. So really, if you think about it this way, the closer my points look like they are lying towards the line, then that's going to be closer to 1. So let me erase these lines because it's kind of hard to see how close they are. All right, so now if I were to look at my choices, let's look at the choices they've given me. This one is 0. This one is a negative 0.87. This is a positive 0.82. What did we talk about earlier about the negative and the positive? This means this is a negative correlation. So I have one that's a negative correlation. So this would be it. So my R is going to equal a negative 0.87. Then I have a positive correlation one, and then I have just a 0, which to me would mean no correlation. So my positive correlation is going to be here at 0.82. And then up here with a no correlation, it's going to be R equals 0. So number 12 says, from number 11, which has the strongest correlation and how do you know? So let me just remind you, our correlations, R equals 0, R equals a negative 0.87, and then R equals a positive 0.82. So remember we talked about this again earlier. A correlation, the correlation coefficient, the closer it is to 1, the stronger it is, the more likely it is modeling the data. So remember, we changed our 1 to 100%, and that way we could look at these as percent. So this would be 0%. This would be a, again, I'm not looking at the negative sign, sorry. I'm not looking at the negative sign, that's just telling the direction of the correlation, so I don't really care about the negative sign. I'm just looking at the number. So this is 87%. And this would be 82%. So which one of these numbers would be closest to 100%? So it looks like it's going to be the one that was the negative 0.87 would be the strongest correlation. Okay, number 13 says the table below shows Mia's bowling scores each week she participated in a bowling league. It says use the line of best fit to estimate Mia's score for week 16. So if we're going to do the line of best fit, again, that's just, we're going to put this in the calculator and we're going to use our linear regression to come up with our equation. So let's do that first. So again, I'm going to start at our home screen just so that we remember how to do this. So I'm at the home screen. I need to go to New Document. Sorry. Okay, I need to go to, maybe not. Okay, let's try this again. I'm at the home page. I want New Document. I don't want to save anything ever. I'm going to add a list or a spreadsheet. In A, I'm going to type an X. In B, I'm going to type a Y. And under, in the A column on row 1, I'm going to start with my week. So it's going to be week 1, week 2, week 3, week 4, week 5, and week 6. I will arrow over and up until I get back to row 1, and this time I'm on the B column. And I'm putting in my scores, 122, 131, 130, 133, 145, and 139. Okay, we're going to stop there, and I'll start back up on the next video.